In this video, we're going to discuss sample spaces and tree diagrams. Okay, actually, tree diagrams are just a tool to help you find sample spaces. And sample spaces are a list of possible events, and sample spaces are really important, especially later when we're calculating probabilities. It's really important to know all the possible events in your sample space so that you can calculate the probability of a particular event. All right, so let's go ahead and get started. We'll do this example here. So what's the sample space for tossing a coin and rolling a die once? All right, so let's see. We need to list out all the possible events, all the possible outcomes that you could observe if you tossed a coin and rolled a die once. So you could get a head, right? I'm going to do H for head. For the tail, for the coin, you could get a head for the coin. And then you could have gotten a 1 for the die. Or you could have gotten a head and a 2 for the die. Another possibility, you could have gotten a head and a 3 for the die. You get the pattern here. So listing out all the different possible outcomes. Could have gotten a head and a 5, a head and a 6, right? No one said you have to have a head. You could have gotten a tails. Tails and a 1, a tails and a 2, a tails and a 3, a tails and a 4, tails and a 5, and a tails and a 6. You could have gotten any of these possible outcomes. So this is a listing of all the different events that are possible. So this is your sample space for tossing a coin and rolling a die once. All right, so this is a real simple sample space. For more difficult sample spaces, so this one, it's simple in the sense that I was able to list it out just by thinking it through, right? A more difficult sample spaces, the tree diagram is a helpful tool for figuring out the sample space. So let's go ahead and use a tree diagram for this simple sample space, and then we'll use it in other examples that have more difficult sample spaces. So in a tree diagram, the first branch of the tree diagram is you could either make it the tossing the coin or the rolling of the die. So I'll make it the tossing the coin. Okay, so listing all the possible outcomes for tossing a coin, could have gotten a head or you could have gotten a tail. Okay, so there was 2 possible options when you flipped a coin. Then from there, there's 6 possible options depending on what you got on your die, right? You could have gotten a 1, 2, 3, 4, 5, or 6. 1, 2, 3, 4, 5, or 6. Okay, and then there's 6 possible options there. Okay, so then when you're reading a tree diagram, you read the first branch H. Then you read 1, so H1, and then H2, H3, H4, H5, H6, which is what we've already listed up top here. All right, then tails 1, tails 2, tails 3, 4, 5, 6, right? So that's the listing that we have here. Right? So it turns out if you multiply the number of possible outcomes for the flipping the coin and multiply that by the number of possible outcomes of rolling the die, so take 2 times 6, this equals 12, and that is the total number of events that you should have in your sample space. So that's a good way to check that you've included all the events in your sample space. If you multiply 2 by 6, get 12. You can check, oh, okay, I have 12 there. So there we go. That's my sample space. All right, so let's do another example. All right, so now let's find the sample space for the gender of 3 kids in a family. Okay, so you could have had all boys, you could have had 2 boys and a girl. You know, we could think of a list and we could create it ourselves, but using the tree, it's a little easier. Make sure that we don't miss anything. So I'm going to go ahead and use the tree. So for the first kid, I could have gotten a boy or a girl, right? So there's 2 possibilities. For the second kid, I could have gotten a boy or I could have gotten a girl. Again, the second kid has 2 possibilities. For the third kid, I could have gotten a boy or a girl. All right, so again, the third kid has 2 options. It could either be a boy or a girl. All right, So 2 options. So if I multiply these together, I should get the total number of possible events that should be in my sample space. So 2 times 2 is 4, times another 2 is 8. Okay, so now let's go ahead and start listing out our sample space. I should have 8 events in the sample space. So I'm going to list it out, B, 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 so that's 3 boys. So I'm going to read my tree branch by branch, B, B, G, B, G, B, B, G, B, B, G, G. So boy and then 2 girls. Okay. Now let's go down to having a girl first. Girl, boy, boy, girl, boy, girl. Okay, I'm reading my branches. Girl, girl, boy, girl, girl, boy, and then 3 girls, girl, girl, girl. All right. So let's see. That's my sample space then. This is a listing of all the different possible events. And let's see, there should be 8 in total. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. That's a good way to check that, make sure I didn't miss any branches of my tree. Great. So there's my sample space for having 3 kids in a family. One more example. So let's see, find how many possible outcomes there are for rolling a die twice. Right, so I'm going to use a tree to do this. I'm not actually going to list all of the possible, I'm not actually going to find the sample space by listing all the possible events, but I'm just going to find how many outcomes are possible. Okay, so for the first die, for the first roll of the die, could have gotten a 1, 2, 3, 4, 5, or 6. Right, so 6 possible outcomes there. And then for the second die, 1, 2, 3, 4, 5, 6. Right, so and then this gets repeated for all of these. Right, so 6 times. Right, so listing this all out would take a long time, which is why I'm not actually finding the sample space here. But there's 6 possibilities for the second die as well. So 6 times 6 equals 36. So there are 36 possible outcomes. If I were to find the sample space, there should be 36 events in that sample space. So how many possible outcomes are there for rolling a die twice? You could list them all out and you get 36 different possible outcomes. Right? You could have gotten a 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, etc.